Our next section is going to be on solving absolute value equations. Now, hopefully from a previous class you remember what an absolute value is. When you see here, we have a situation where we have the absolute value of x equals 3. And so we need to remember an absolute value is a distance away from 0. And so it's asking what numbers have a distance from 0 equal to 3. That's what that question is asking, and that's what we're going to answer today. So we have two different problems we want to look at here. We want to discuss what is the difference between our first situation and our second situation here. We start with x equal to the absolute value of 3. That simply says to find x, take the absolute value of 3. Well, 3 is 3 units away from 0 on a number line, so therefore x is equal to 3. The second question, the absolute value of x equals 3, becomes slightly more complex because it's saying what numbers are 3 units away from 0 on a number line. In other words, we took an absolute value of a number and got 3. What number must that have been? Well, that number could have been 3. Or there's another solution, because 3 units away from a 0 on a number line, there's no restriction on what direction we go. 3 is 3 units away from 0 on a number line. But so is negative 3. So therefore, this equation has two solutions. X equals 3, x equals negative 3. Some of you are going to ask the question, can we write it like this, plus or minus 3? Yes, you can, as long as you understand this represents two solutions. People misuse that plus or minus, and they forget that it actually represents two different answers. So what this brings us to is our question at the bottom of the screen here. What allows an absolute value to be removed when solving an equation? Because when we solve an equation, we want to take the equation apart and eliminate everything but x. So therefore, what allowed that absolute value to be removed is to consider the definition of an absolute value. If we have the absolute value of x equals 9, to rewrite that without an absolute value, we have to account for the fact that we have two different directions we can go from 0 on a number line. So to remove an absolute value, our inverse operation step that we've been talking about throughout this chapter, the inverse operation that allows us to go from the absolute value of x here to just x here is you need to create two separate solutions. You need to simplify that down so it's two separate answers, because an absolute value could be positive or could be negative. So that question we just answered is an important one because it allows us to now solve absolute value equations where there's operations inside an absolute value. Because we said from our previous screen, right now we need to get rid of those absolute value lines. I cannot do this. Add 5 to both sides. You cannot do that. These absolute values lock that 2x minus 5 inside. We need to make that absolute value go away so we can add that 5 to get x by itself. So the step we learned in the previous page was, if I have an absolute value equal to a number, I can set that absolute value equal to both a positive 13 and a negative 13. Because an absolute value, we don't know what's inside there. That 2x minus 5 could be 13 because the absolute value of 13 is 13. Or 2x minus 5 could be negative 13 because the absolute value of negative 13 is also 13. So as many of you are noticing here now, the situation is we have to do a little bit of extra work. Anytime you're solving an equation with an absolute value in it, you're going to get two solutions. Let me rephrase that. Most of the time, you're going to get two solutions. We'll talk about some special cases tomorrow. But we're going to have to split the equation to get rid of the absolute value bars. In order to take that step where we can solve our equation without the absolute value, we had to split it into two separate equations. From there, we do our basic solving, giving a solution x equals 9. Then we have to go back and start the whole problem over again. Add 5 to both sides. Divide by 2. And get x equals -4. So you now notice here we now have two unique solutions. They're not opposites of one another. Don't just assume everything is going to be a plus or minus situation. In this case, we have two unique solutions. And as always in algebra, you can check your answer by plugging them back in. 2 times 9 is 18, minus 5 is 13. The absolute value of 13 is 13. If we plug -4 back into the original, 2 times -4 is -8. -8 minus 5 is -13. But the absolute value of -13 is 13. Our second situation that we have to be concerned about is an operation that occurs outside of the absolute value. When you have operations outside of the absolute value, you need to solve those first. In other words, we need to get the absolute value by itself so that we can split it into two separate equations. So we follow all the same solving steps we've been using for years. To get rid of +5, you minus 5. To get rid of times 3, divide by 3. Now we have an absolute value by itself. So we solve that by splitting it into two separate equations. X could be 2, x could be -2. So now we're back to our plus or minus situation. So this brings us to our final, put it all together, giant problem of the day. And so for our giant problem of the day, we have operations on the inside and operations on the outside. We always start outside the absolute value if we can. We want to get that absolute value by itself. So I always get rid of adding and subtracting first, plus 9. Now a lot of people would say, why not -7? Remember, those absolute value bars lock that 2x plus 7 in. I cannot do anything to the things inside the absolute value bars. Now, I still can't get rid of the absolute value bars because that 4 is there. So I divide by 4 on both sides. Now, we have an absolute value by itself. Now we're back to this situation. Now we're back to this problem. Absolute value equals a number. So we can follow that pattern that said, once I have an absolute value equal to a number, I write it as two separate equations. One equal to a +5, one equal to a -5. And solve both of those equations. X is -1 is one of our solutions. X is -6 is our other solution. If you would go back to the original problem, you could plug both of those in and they would both check. They would both work as solutions. Now, on some of your problems on your homework, you may get some nasty fraction answers. That's okay. Just leave them in fraction form. They won't all work out to nice whole numbers. All right, so that is solving absolute value equations.